Hey guys, this is Fozon, and in today's lesson we're going to be discussing algorithms that we can use with arrays. So our lesson objectives, these are just some standard algorithms that utilize array traversals. So array traversals are a heavy component of these standard algorithms. So algorithms that we will be developing: finding a minimum or maximum value, calculating a sum and average, determining a particular property within the array, finding duplicates, determining the number of elements that fall under certain criteria, shifting elements to the right or left, and reversing the orders of the elements. I recommend developing these algorithms prior to, well, when I cover them in the video. That way that you can get some hands-on experience prior to me giving you the answers. However, if you want to go through the compiler or watch this video rather, it's all up to you. You'll learn just the same. Alrighty, so on to the compiler. First thing I'm going to do is I'm going to create the minimum value algorithm, meaning that we'll make an algorithm that traverses through an array and finds the minimum value within the array. So just to keep things simple, I've created an integer array with some standard values, 5, 4, 3, 2, 1, and we have a print array method. Now the difference between this print array, well, not really the difference. Now that you've gone through the array traversal video, now you know how this for each loop works, rather than the arrays video where I just simply said this method simply prints out print array. But anyway, the point of this video is to get the algorithms down. So let's start with creating a find min method. So public static void find min. Now depending on how you want to go with this algorithm, you'll change the return type. So if you want to return the minimum value, you can make that respective change by changing this to int and then returning the minimum value. However, just for the sake of this video, I'm going to make this print out the minimum value. Let's make a for each loop. So we make a for each loop, and then we have the data type that we have within our array. Within our arguments, we have integer array, so we're going to be traversing through an integer array. So the data type within our array is integer. The value that we're going to be seeing, or the element of the array that we're going to be seeing at iteration, is going to be known as val during each iteration, and it's going to be traversing through the array within our arguments. Now, instead of declaring the minimum value within the for loop, I'm going to declare it outside the for loop. The reason why I do this is because after every for loop iteration, it's going to go out of scope, meaning that integer minimum will no longer exist when I leave the for loop, nor when I'm trying to compare it to other elements within my array. So I'm going to store it within integer minimum. I'm going to set it equal to integer dot max value. Now you're probably wondering, why don't I use the min value? Well, you see within our algorithm that we want to start off with the biggest element, and then we'll work our way down. If I already start off with the most minimum value that Java can store, that means that will be the most minimum number, right? No array element will be more minimum than the integer min value. So we're going to start off with the max value because no number can be bigger than the max value that the integer can store. Now let's make an if statement. This Boolean expression will evaluate to true when the value that we have currently is less than the minimum. And if that is true, that means that we found a value within our element that is less than the minimum value. If it finds the minimum value, it's going to set minimum equal to the new value that we found, and that becomes the new value within the new minimum value within our array. After the for loop, I'm going to print out the minimum value. And then I'm going to concatenate that with the minimum variable. Hopefully it will work and find that 1 is the minimum value. So let's call the method. rather than printing array, what I'm going to do is I'm going to make a call to this method, find min, and let's call the a method, a integer array. Okay, and it finds out the minimum value is 1. Let's change it so that it returns an integer rather than printing it out within this method. So let's do this. Integer min is equal to find min. Let's make the respective change within the method declaration. So instead of not returning anything, it's going to return an integer. And then instead of printing it, it's going to return minimum. Let's print it out from the main method. And as you can see, it still prints out 1. Remember and adjust to your context. So if your AP exam requests you to return an integer, remember to have a print statement. But if your AP exam says, hey, it's a void declaration, make sure to make that respective change and then maybe print it out if it asks you. Using this, we can actually create our own find maximum method. So what I'm going to do is simply copy this, and then I'm going to paste it underneath it. Now we have to make different changes to adjust so that we're finding the max value rather than the minimum value. First things first, let's change the method declaration to find max. That way it doesn't confuse between find minimum and find max. We'll keep the integer array argument as well as the other parts of the method declaration. To reflect the context of our integer, let's change this from integer minimum to integer maximum. And since we want to find the maximum value, let's start at the minimum value. That way, the first integer that it finds, it will automatically be set to the maximum. Let's replace the other instances of minimum to maximum. Now we have to change the Boolean expression within our if statement to reflect that we want to find the maximum value. So if every iteration we find a bigger value than the previous maximum value that we have, then we want maximum to equal val. So let's change the operator to greater than rather than less than. Let's test to see if this works. So rather than having find min, it's going to have to find max. Let me replace this with max and this with max. With this integer array, it should hopefully print out 5. And as you can see, it prints out 5. For our next algorithm, we're going to develop a sum and average calculation. So let's do that. Let's do public static void find sum. And it's going to take in an integer array declaration, just like most, if not all, of the method declarations for every algorithm that we're going to be developing in this video. For this one particularly, I'm going to have an integer value. You're going to understand why after I use this find sum method to calculate the average. So to calculate the sum, we're going to need a for loop. So let's make a for loop. Integer val array. So val is going to be the integer of every element through every iteration. So every iteration is going to have a new val, and that's going to be reflective of what position it will be at every element within our array. We're going to store the sum outside the for loop, again reflecting why we need reflecting our scope rules. If we declare sum within our for loop, it's going to always be set to 0, and when we're trying to return it, it's not going to be existing because it's going to be out of scope, meaning that you can't access it. We're going to set sum equal to 0 because the sum will start at 0. Now, every time we iterate through a new val, we're going to add that to sum. So sum is going to be equal to sum plus val. So sum is equal to sum plus val, meaning that the old value of sum is going to be equal to the old value of sum is going to be equal to the new value of sum is going to be equal to the old value of sum plus val. Right, I mixed old and new there. Then we're going to return sum. Let's see if this method works. So what we're going to do is replace this with sum, replace this with sum, and rather than finding max, we're going to do find sum. So let's see. We have 5, 4, 3, 2, 1. What does this add up to? Well, we know that 1 plus 2 plus 3 is equal to 6. 6 plus 4 is equal to 10. And then 10 plus 5 is equal to 15. So hopefully the sum should return out 15. And it prints out 15. Let's use the find sum method in our calculating average program. So to calculate the average, you would need to find the sum of all the values and then divide it by the array length. So let's do that. So we're going to do public static integer find average, and I abbreviated average. So the first thing that we want to do is find the sum. Rather than creating another find sum algorithm within our method, we could just invoke the find sum method that we already created. So we could do integer sum is equal to find sum, and then our integer array argument. And let's not make that integer declaration. We're simply going to name that Ari. Now let's make the respective calculation to find average. So we're going to have the average as a double value. And then we're going to set that equal to sum divided by Ari.length. Ari.length is simply the number of elements that we have within our array. So if we already have the sum of all the values, and we have the number of elements, we could simply divide that to get the average. Recall that when we do integer division, it's simply going to cut off the decimal. So let's cast that and make it a double. By casting it, it allows us to convert this into a double, and then when it realizes that, hey, we have when we have a double value, it's going to return us a double when it divides, rather than simply cutting it off and giving us an inaccurate result. Rather than returning an integer, let's return a double. And let's return the average. Alrighty, so now let's create this and set that equal to find AVG. And then this will be AVG. What do you think the average will be when we execute this program? Well, 15 is the sum, and what are the number of elements do we have? So it's going to be 15 divided by 5. Our average is going to be 3. So hopefully, when we execute this, it's going to print out 3. Let's change this from an integer to double, just to make sure that we have the correct values. And as you can see, it returns 3.0 rather than 3. If we maybe added 6, it might return us a decimal, depending on it. Yes, and it returns us 3.5. Luckily, we casted that within our average calculation, and rather than keeping it as an integer, we converted it to a double, because if it stayed as an integer, it would have cut off the 0.5 and left it as a 3, and that would be very inaccurate. Now let's do one that finds particular properties within our array. A prime example of this is to check if everything within the array is an even number. So let's do that. So public static boolean, since we're returning true or false, and let's see if it checks even. And it's going to take in integer array arguments. Now, we're going to declare a Boolean value outside the for loop, again, so that we can return it once the for loop is done executing. Let's set this equal to true. Now, within our for loop, within our method, we're going to create a for loop. Let's make a for each loop. Now within our method, we're going to see whether or not if they are a even or odd number. So the way that we find whether or not if something is an even or odd number is doing modulus 2. If we get a remainder of 1, then it's an odd number. But if it stays as a remainder of, sorry about that voice crack, but if we get a remainder of 0, it's an even number. If we get a remainder of 1, it's going to be an odd number. So let's make an if statement that checks to see whether or not if it has odd numbers. We've already set it to true, meaning that if this for loop was running, if this for loop wasn't there, it would return true. But we want to check for odd numbers, and if it's an odd number, it's going to change this from true to false, meaning that we have odd numbers within our array. So let's make that Boolean expression. So if val, since that's the number at every iteration, modulus 2 is equal to 1, that means it's an odd number. So this is no longer an even array, it's an odd array. So we're going to return even is going to be equal to false. And then we're going to return Boolean. We're going to return the Boolean value even. Let's see if this works. So we have an array with even and odd numbers. So hopefully this should return false. I'm going to delete this, and then I'm going to simply call the method within the array, within the print statement. So check even, and then let's put in our array arguments. And it luckily prints out false. Technically speaking, we can avoid this Boolean expression altogether. Let's do that. Let's eliminate this. And then rather than accessing a Boolean expression within this value, let's just simply return false when it finds an odd number. When it returns false, it simply ends the method right there without even looking at maybe finishing the for loop or this statement at the end. It will just return false. So if we find an odd number, we know that this array is going to return false no matter what. So we're just going to return false since we found an odd number. If it goes to this for loop without invoking the return false value, then we know it's an even array because this if statement was never executed. And if the if statement was never executed, that means all the values within our array are even numbers. So in that case, we're going to return true. Hopefully we should get the same result if we execute the program. And as you can see, it returns false. Let's try another array just to see if it returns true. I'm going to do integer b, and then I'm going to erase all the odd numbers. So we have an array with even values. Hopefully this if statement will never get invoked. And rather than putting b in the arguments, I returned a. So let me put b in the arguments. And it returns true because I have a b array with only even numbers, and this if statement never gets invoked simply because there's no value within our array that is an odd number. Let's make a program that finds particular properties that fall under certain criteria and the number of elements. So I've already showed you how to do a check even algorithm, meaning that it checks to see whether or not if there are even values within our array. However, we can also return the number of elements rather than just simply returning whether or not there are even numbers or not. So let's do that. So in this case, we're going to have to declare an integer outside of the array. So let's do integer, and let's do number of elements. Actually, what I'm going to do is create another separate method altogether. This way that we can implement this algorithm later on. So I'm going to simply just copy this and then paste it. And I'm going to change the method declaration. So let's do elements that are even, and then we're going to find the number of elements that are even. So elements even. We're going to set that equal to 0. Now it's going to loop through the entire value. It's going to loop through the entire array through our for each loop. It's going to loop through every element of the array. And we want to see whether or not each element is an even number. And if it's an even number, it's going to increment this value by 1. So let's do that. So rather than checking for odd numbers, it's going to be checking for even numbers. So we replace this with 0. Then if this gets invoked, that means that we can increment this value by 1. Elements even 1. This is the same thing as elements even is equal to elements even plus 1. And then after the for loop is done, we can return an event elements even. Let's reflect our return type into our method declaration. So rather than having a Boolean return type, we're going to have an integer return type. This will check to see how many elements that are. This will check to see how many elements are even numbers. There are so many algorithms here that I'm mixing and maxing them all together, but hopefully this one will work. So just to recap, it's set to 0, meaning that the number of elements that we have originally are going to be 0 that are even numbers, and then whenever it finds an even number within the array, it's going to increment this by 1, and it's going to return the number of even numbers within our array. So let's call the method elements even, and then give it the argument integer array a. Let's make sure that there is nothing completely wrong, or the syntax isn't wrong with this. The syntax isn't giving me any issue, so hopefully it will work. And as you can see, it returns 3. 3 is the number of even numbers that I have within my integer array. So we have 6, 4, and 2. So that makes it 3 even numbers. You can do this with objects as well. However, you might need to utilize an accessor method on top of that. Let's now do a method that finds duplicates. So this one's a little bit fun in that it might utilize a different way of thinking. So let's do public static void find dupe. Hopefully that's an appropriate method name. And then our integer array arguments. So what we're going to do is we're going to compare every value within our array with respect to each other. Meaning that I'm going to declare the first element with all the elements. I'm going to compare the second element with all the elements, including the first one. So we're going to continue that. Sorry about that. I went a little bit off track there. But yeah, let's work on this. So we're going to do for integer val. And what we're going to do is we're going to traverse through. Actually, this one will be more appropriate and would probably be more easier if we do the standard for loop. So we're going to do for integer I is equal to 0, I is less than re.length, and then I increments. Hopefully it should be good. I haven't declared I yet, so yeah, there you go. Now it should be colorful. Now you're probably wondering why I use the integer I. Well, the reason why is if we want to compare it with respect to each other, we don't want it comparing it to itself. And if it compares it to itself, it's going to obviously think that there's a duplicate. So in that regard, we want to avoid that problem rather than using a for each loop that doesn't keep track of the loop control variable, or rather the position that it's at with respect to another position that it wants to locate or comparing it to. So let's make another for loop. Integer j is equal to 0. J is less than re.length. And then j increments. Okay, that should be good. So we want to compare with every iteration one value to all the values or the rest of the values within our array. So let's keep track of that value. So we're going to do integer current val is equal to re, and then let's access the value that we're comparing to the rest of the array at every iteration. In this case, we're going to be using a nested for loop for our algorithm. Now we want to make sure that we're not comparing the value that we're currently at to itself. So let's make sure that we don't do that. So let's make an if statement. And it says that as long as I is not equal to j, as long as I is not equal to j, what it will do is that it will compare the value. Because if I is equal to j, then it's comparing it against itself. Now you're probably wondering how it would be comparing it against itself. Well, you'll see when we implement the if statement again. So we're going to use if statement, and then we're going to compare the current value that we're at with the value that we're comparing it to within the array. So current val is equal to re.j. In that case, it has found a duplicate. So let's make a Boolean expression that shows that we have a duplicate. So let's set that equal to false. So Boolean C, or let me do Boolean A is equal to false. Actually, C, good. And if it finds a duplicate, then we're going to make this true. Now, I just threw a lot of if statements and for loops at you. So let me cover this through so that it makes a lot more sense. So we have a for loop. What this for loop does, well, the outer for loop, what it does is that it compares every value. It gives us a current value, a value that we want to compare to the rest of the array. Now, what this for loop does is that it allows us to get the values of the other elements of the array and then compare that to the value that we have. What this if statement does is that it makes sure that the value that we're currently comparing it to the rest of the elements is not equal to the same thing, or not the position that it's at. So I don't want to compare position 3 to position 3 because I know that the same value is stored within the array. I want to make sure that position 3 is being compared to position 1, 2, 4, 5, 6 within my array, not position 3 against position 3, because I already know that that is going to be technically a duplicate, but it's the same thing altogether. Now, if it finds the value that we are comparing at another array element, then it's going to make this Boolean expression true. Now, what do we do with that once it converts to true? Well, let's make an if statement after this for loop's execution is done. So we have this curly bracket and it ends with this curly bracket. So if C is equal to true, technically speaking, you can omit that and just leave that as B, the Boolean expression that we have here. What it's going to do is that it knows that we have found a duplicate within here. We found a duplicate within our array. So it's going to print out the value C. It's going to print out the current value. meaning that it has found a duplicate, meaning that this if statement has eventually returned, this if statement was true, and it found, well, a duplicate at that moment. Let me add a space just to make sure. Since this is a void statement, since this is a void method declaration, it's not going to return anything. So hopefully it will print out all our duplicates. Again, look at our method before I go back to the main method to see whether or not it works. Alrighty, cool. So now what I'm going to do is I'm going to access the find dupe method. Actually, since it already includes its own print statement, I don't need a print statement around the method declaration. And then I'm going to remove the extra parentheses there, and hopefully it should return nothing when we run the program. And as you can see, it returns nothing because in integer array A, it doesn't have any, well, duplicates within it. But let's find it, or let's create our own duplicates to this. Let's maybe put 3 just for good measure, and then maybe 2. And let's put 0. So within our array, we have 6 as a duplicate, we have 4 as a duplicate. We don't have 3 as a duplicate, but we have 2 as well as a duplicate. So hopefully it should print out 6, 4, and 2. Let's try that when we replace the arguments with our second integer array. And as you can see, it prints out the values that we have as 6, 6, 4, 4, 2, 2, 2. Those are our duplicate values. We can also edit that program, and I'll leave that up to you so that it only prints out these values once, and it removes it from our iteration, or skips it rather than, you know, printing all the values that are duplicates, because it prints out 6, 6, 4, 4, 2, 2, 2, 2, because it finds whether or not these are duplicates within there. You could also edit this algorithm to take in an integer argument as well and see whether or not if that has a integer, whether or not to see if that has a duplicate in there. So I'll leave that up to you, and I'll leave a solution in the description, hopefully. Now let's shift the elements. Within an array, and then maybe put an element within position 0. So let's do that. So public static void, that's a main method, and let's do shift, and then it's going to take in an integer array argument. So to shift the elements of an array to the right, we need to increase the array size by 1. So what I'm going to do is I'm going to return an integer array. And that integer array is going to be the array that we reverse. The integer that we're going to shift. Reverse is the next algorithm. So integer, let's do the second array. And then we're going to set that equal to a new integer array. And within our new integer array, it's going to have a size of RE. It's going to have the number of elements that we have in RE, or the arguments that we have, the integer argument that we have, plus 1. So the number of elements that we have in this array, well, this array is going to have that plus 1. So the way that we can do that is simply accessing the number of elements that we have within our argument arrays, and then, well, plus 1. Now what we can do is create a for loop. And rather than creating a for each loop, I'm going to create a regular for loop. So I'm going to do integer I is equal to 0. I is less than re.length. And then I is going to increment. Now what I want to do is make sure that everything is being shifted by 1. And in this case, we're going to have it set so that everything that we have in this array is going to be whatever is in this array plus the +1 with regards to their position, meaning that second array should have a value of 0 as its first array element, So to do that, we need to find the value that we have at position I at every iteration. So integer current val is equal to array and then the value that we have at I position. Then what we're going to do is set current val and assign that to the second array's position, but +1. So whatever the position array in that I is, the position that we're at currently, we're going to just simply increment that by 1 and then put that at the position that we just found in the second array. So let's do that. So it's going to be let's make integer second position, and we're going to set that equal to I +1. So that's going to be the position that we put within the second array. Let's do that. And that's going to be the position that we just calculated. And then we're going to set that equal to the current val. After this for loop is done, we can return the second array. Technically speaking, we can simply avoid all of this. Well, not avoid all of this, but we can minimize this all into one line. So let's do that. So we want to assign a value into the second array. So we're assigning a value to the second array. But what position are we assigning the value to? Well, we're assigning it to technically I +1, or the next value after position. We're shifting it by 1. And what value are we actually shifting at that respective position? Well, it's going to be the element that we have at array and the I value, at the I value. So we're going to do array I. This avoids the hassle of creating extra variables that we won't need. Let's see if this works. So rather than having find duplicates, what we're going to do is we're going to do print array, and then within the print array method, within the print array invocation again, and then we're going to do shift, and then we're going to shift array A. And as you can see, it shifts the values of the integer array by 1. 0, 6, 5, 4, 3, 2, 1. And the value that we have there can be any value that we want to set there. We could do that with maybe another argument, or we could do that within the main method. Maybe we don't want to shift it by 1. Maybe we want to shift it by maybe a value of 2 or 3. Well, we can do that. Let's make another integer array argument. Let's do integer shift value. And after every shift value, rather than having 1 as our shift value, we're going to have the shift value that we use in our arguments as a shift value. That could be 1, but it could also be 2. Let's make sure the precondition is a value greater than 1. Greater than or equal to 1. Now let's input an argument. So let's keep it the same. Maybe we want to shift it by a value of 1. Let's see if that still works. And as you can see, it still has that value 6, 5, 4, 3, 2, 1. But now let's change it so that it shifts by maybe a value of 3. Well, it makes that respective change, and as you can see, we have 3 0 values because that's the automatic initialization of a new integer array. Finally, what I'm going to do is reverse the elements of an array. So let's do that. So we're going to do public static void reverse, and then it's going to take in an integer array. Okay. Rather than having a void return type, I'm going to do an integer array return type. That way we can print it out later on from the main method. So let's do this. Let's do integer, and then this is going to be the reversed array. So we're going to have an integer array, and we're going to store it as the reversed array. Let's set that equal to new integer, and it's going to have the same length as, well, the array that we have in our arguments. It's reversed. We're not shifting it by any values, hopefully. Now let's create a for loop. So what we're going to do is do for integer I is equal to 0. I is less than array.length, and then we're going to increment that by 1 through every iteration. On top of that, what I'm going to do is create an integer j. This will serve not necessarily as a loop control variable, but as a way of accessing or setting values or getting the position of the elements in reversed array. So if I want to assign a value in a reversed array, I can't use I, because I is the value that I'm using to access elements of Ari. So I have to create an integer j that is the complete opposite of integer I. So that's going to simply be array.length. Now recall that, technically speaking, the length cannot be used as a position because it's greater than 1 of the maximum position that we have, because it starts at 0, but the number of elements starts its count at 1. So we're going to simply subtract 1 from it. So this is the final or maximum position that we can have in both of these arrays. And we're going to use this to assign values in reversed array. Now let's assign the values. So what I'm going to do is I'm going to access what position that we want to assign a value into reversed array. So let's access reversed array, and then let's access the position. I use j as my way to access the position, and then I'm going to simply assign that to the value that we have using I within our original array. So if we have, let's say, a length of 8, if we have a length of 8, I is going to start at 0, and then j is going to start at 7. And then after every iteration, the I is going to increment, and then j is going to decrement. Eventually, I is going to hit the array.length size, and then j is going to hit 0. Or rather, -1, technically speaking, because 0 isn't a viable position. But once it hits -1 and I hits the array.length, then we don't want to reverse any more elements because we've already reversed all elements. We want to ensure that j gets decremented. So let's do that after every iteration. This is the equivalent of saying j is equal to j minus 1. Now let's return the reversed array. Okay, now we're going to test whether or not this reversed array algorithm works. So we're going to access reversed array within our print array method, because our print array method requires integer arguments, and the reverse method that we have returns an integer array. So let's do that. So print array reverse, and then let's put in our integer array arguments. Hopefully it should return 1, 2, 3, 4, 5, 6. We have no compilation errors. And as you can see, it returns 1, 2, 3, 4, 5, 6. There are so many other algorithms that you can utilize with ArrayLists. With arrays. ArrayLists will be another video, and they require a little bit more of a different syntax. But just for this video, arrays, these are the standard algorithms that you can utilize with arrays, and there's so much more that you can make with arrays. These are just some basic algorithms to just get you started and help you get used to array traversals. So hopefully this video is not a summary of what you can potentially do, but rather a stepping stone of something much greater. Thank you for watching my video.